Okay, now we are going to solve a question based on Laplace transform. Find the Laplace transform of x of t is equal to e raised to a t u of t. Okay, let us start to solve this problem from the basic equation for the Laplace transform. We know that the Laplace transform of any continuous time signal x of t, that is denoted by capital X of s, and mathematically it is defined by equation integral minus infinity to plus infinity e raised to minus st x of t dt. This is the basic equation for Laplace transform. But here it is given that x of t is equal to e raised to minus at u of t. Then you should know what is the significance of this u of t. In the given signal x of t, it's given e raised to at into u of t. Then you should know the significance of u of t. Actually, u of t is a unit step signal, u of t. Okay, the value of u of t is equal to 1 from t equal to 0 and it tends to infinity. Means the value of t will be 1 from t equal to 0 to t equal to infinity. Okay, okay, right. Then if we multiply this signal with e raised to at, what will happen? That we can replace u of t with 1, e raised to at into 1, only from t equal to 0 to infinity. What about from t equal to minus infinity to 0? Here it is 0. Okay, now let us substitute x of t in this equation. Say equation number 1 and this is equation number 2. If just substitute equation 2 in equation 1, then we are getting x of s is equal to minus infinity to plus infinity e raised to t. Then in place of x of t, we can write e raised to minus at u of t. Okay, right. Here we can replace with the corresponding signal given. E raised to minus at u of t, then followed by a dt. Okay. Now let us split the limit of integration into two subparts. One from minus infinity to 0. The same signal, this one. Okay. E raised to ft, e raised to at, u of t dt, plus then the second limit starts from t equal to 0 to infinity. Okay, this is split into two sub intervals. Okay, right. One from minus infinity to 0 and another from 0 to infinity. E raised to minus st, e raised to minus at, u of t dt. Okay, then let us substitute the values of this u of t. Okay, what is u of t? We know that u of t is equal to 1 only from t equal to 0. Then what about the value of u of t from minus infinity to 0? That is equal to 0. Okay, from minus infinity to 0, e raised to minus st, e raised to at, u of t, the value of u of t within this interval minus infinity to 0 is 0. The signal doesn't exist. Okay, so we can replace u of t with 0 plus 0 to infinity e raised to minus ft e raised to minus at. What about the value of u of t within this interval 0 to infinity? Value of u of t is equal to 1 from t equal to 0 to infinity, from t equal to 0 to infinity. So we can replace u of t with 1. Okay, Then this becomes 0. Only the limit of integration exists is from 0 to infinity. Okay. Then a raised to m into a raised to n format. We know that a raised to m into a raised to n is equal to a raised to m plus n. Okay. If we apply this formula, in this case, we are getting e raised to minus st into e raised to minus at. So let us write it as e raised to st plus minus at. Okay, then into 1 become that quantity itself. Again, this is equal to 0 to infinity e raised to, I'm taking this minus into plus, of course that changes to minus. So minus is common in both case, so I'm going to take it outside, then the remaining thing we are getting is this one. Okay, right? And d of t. Then let us integrate this exponent. We know that integral e raised to at dt, that is equal to e raised to at divided by d by dt of, okay, d by dt of at. Okay, now let us apply this formula for integration here. Then I'm getting, in place of at, here we have e raised to minus s plus a into t. Okay, so if we integrate, if we apply this formula, I'm getting e raised to minus s plus a into t itself divided by, okay, divided by d by dt of what is in the exponent. Okay, here we have minus s plus a t within that integration limit. Okay, right. Now let us solve this. A raised to minus s plus a into t divided by, what about this one? This one become minus s plus a. Okay, now let us take this 1 divided by minus s plus a outside, then sorry, then I'm getting e raised to minus s plus a into t within this integration limit. Okay, now let us substitute the upper limit, then minus lower limit s plus a. If you substitute the upper limit, I'm getting e raised to minus s plus a into infinity. Okay, minus, put the lower limit also, e raised to minus s plus a into 0 by s. Okay, into, what about this one? E raised to minus infinity. Okay, right, minus e raised to 0. Okay, 0 into this become e raised to 0. Okay, what about the value of this one? E raised to minus infinity is equal to 0. So actually what we are getting is, this is equal to 0 minus value of e raised to 0 is equal to 1. Okay, then this minus and the minus will be, when multiplied together we get 1 by s plus a. That is the Laplace transform of x of, Laplace transform of given signal e raised to minus at u of t. Laplace transform of this one is equal to x of s, that is equal to 1 by s plus a. Okay, thank you.